Hey guys, sorry I'm not here today, but as you know, I had to go to a meeting. So what you're going to do is you are going to follow along with me and work through the worksheet that was given to you by the sub at the beginning. First, we are going to solve systems of quadratics and linear equations. Remember, quadratics is a parabola, so our x squared functions, and linear equations are lines. So we want to see where these two systems intersect each other. So the first thing we're going to talk about is if a point that is given to me is going to be a solution, meaning is this point a point of intersection between the two graphs, right? So my first one right here, I have x squared plus y squared minus x minus 5y minus 26 equals 0, and x minus y plus 1 equals 0. So when we test it, what we have to do is actually plug in -3 and -2 into both equations. Both equations have to be true for me to say, yes, this is a solution, okay? So some of you might notice that in this top equation, I have an x squared and a y squared. That means this guy is fancy. This is technically a circle that we're dealing with. So we have a circle and a line here. All right, first things first, I'm going to take my point, -3 and -2, and I'm going to plug it in to my line, only because it's an easier equation. I like to work with easy stuff. So we're going to have -3 replace the x, subtract my y, which in this case is -2, then I'm going to add 1, make it equal to 0. -3 minus -2 is +2, plus 1. -3 plus 2 is in fact a -1. -1 plus 1 is 0. That is a true statement. So far this point is working out for me. All right, now I have to take the point -3, -2 and plug it into our circle. So wherever I see an x, we're going to replace it with a -3. And wherever I see a y, I'm going to replace it with a -2. Okay, so I've replaced everything in there. I always do parentheses, that way my sign stays with my numbers. All right, -3 squared is 9, -2 squared is 4. Subtracting a -3 is saying adding 3. Then we have a +10, subtract 26. All right, 9 plus 4 is 13, plus 3 is 16, plus 10 gives me a +26. And then when I subtract 26, I get a true statement again. So since this point worked out for both of these, I would say yes, that this is a solution. So yes, all right, the point -3, -2 is a point on the graph where these two are intersecting each other. All right, so now you are going to try number 2. Go ahead and push the pause button. I want you to try it on your own, and then when you push play, we will see the solution together. So go ahead and push pause. All right, guys, so here is number 2. When you plug the point into the parabola on the top, we did get our blue equation of 0 equals 0, which is a true statement. Then when we plugged it into our line, we got 4 equals 4, which is also a true statement. So we should say that yes, that the point 4, 0 is going to be where this line and this parabola intersect each other. All right, we have one more. Go ahead and push pause again and try number 3, and then come back and see how you did. So here we are looking at number 3. It does not matter which equation you picked to plug in the point of 6 and -6. I just chose the top one because my x squared was positive. So when I plug it in, I had to make sure I keep my -6 with my y and my 6 with my x. I end up with the statement of that 20 equals 0, and that is not true. 20 does not equal 0. Therefore, the point of 6 and -6, it is not a solution, okay? If I were to graph, this is actually 2 circles here. If I were to graph these two circles, they would not intersect at the point of 6 and -6. All right, so on the worksheet that you have in front of you, please go ahead and work on 1, 2, 3, and 4. Pause the video, work on those, and then come back to see how to solve the system by graphing. Okay, we are going to move on to solving systems of quadratics and linear equations. There are 2 different strategies we're going to use. graphing and substitution. Today we're going to focus on the graphing part. Okay, so when we graph these two, we're going to get something that looks like one of these three, right? Remember, what are we looking for when I'm talking about a solution? We're looking for where they intersect each other. So the first graph, they never cross each other's paths, okay? So my first graph actually has 0 solutions, okay? They will not cross each other. My middle graph, you'll see right at this point, they are touching each other at exactly one spot. So this one has 1 solution. And if you remember back in your geometry days, this has a special name. It is called being tangent to one another. Okay, that is when two graphs touch at exactly one point. And our last graph shows me where my line and my parabola are intersecting at 2 different spots. Therefore, this one's going to have 2 solutions. Okay. Remember, when we're looking at intersecting points, we have an actual point. So your answer should be in a coordinate point. So 1 solution, you get 1. Our 2 solutions, you should actually have 2 ordered pairs of where they are intersecting each other. Now we have a tool called a graphing calculator that is going to help us find the exact intersecting points of our 2 graphs. So here we go. I have a blue parabola that goes with the equation y equals x squared minus 2, and the red line is y equals x plus 4. They are crossing each other at 2 different locations. All right. I see one happening here, and I see one happening here. Our calculator is going to help us find these points. So you need to first put these into our graphing calculator. All right, so remember we push y equals. We need to type it in, x squared minus 2. My next line is going to be x plus 4. And I push our graph button. It should show up for us nice and pretty. There's the parabola. And there comes our line. All right, step 2 tells me I need to press the second trace 5 and move my cursor. All right, let me show you. Second, your trace button is in between zoom and graph. Then you're going to go down to option 5 because option 5 gives you the intersect option. I want to calculate the intersect. Okay, it's going to ask me the first curve. I need to move my cursor to the first point in which I want to find. So I'm going to move it over here. Okay. We will then push the enter key 3 times. So first curve, second curve. It wants me to guess it. I'm going to say yes. And it shows me that the intersection point is at -2, +2. Okay. It tells me at the bottom of my screen that the intersection is at -2, +2. Now I want to do the same thing again, but looking for the point on the other side. So I'm going to go to my calculator. Same thing, second, trace, option number 5. We need to move our cursor now to the right-hand side, get as close to that point as possible. And now we're going to push enter 3 times. So 1, 2, 3. And it shows me that my final intersecting point is at 3, 7. All right. We want to use this strategy when we have an x squared in our 2 equations, right? Because remember, when we graph, we have to get y equals by itself, right? We need to isolate the y equals. If I did that over here with the y squared, there's going to have to be a square root involved, and I really don't want to mess with that. Over here, I notice that both of my y's have a power of 1. So therefore, it's going to be a little bit easier for us to get the y's on their own when we only have the x being squared and not the y. All right? Let's work on this one together. X squared plus x minus y plus 63. And then we have x plus 3y equals -3. So I do have a parabola up top and a line underneath it. I need to isolate my y's. So my first equation, you could subtract x squared, subtract x, subtract 63, or you could take -y and just add it over. I have isolated the y. I now have y equals x squared plus x plus 63. Right? My line, we're going to isolate it. I have to first subtract the x over to get 3y equals negative x minus 3. I write my x first because I want my line to be in slope-intercept form. I then have to divide by 3, all pieces. So I'm going to get y equals, technically there's a negative 1 in front of that x, so that becomes negative 1/3 x minus 1. So since I have now isolated my two functions, I am going to graph them. So here we go, my calculator, y equals. This is now going to be x squared plus x plus 63. And our second equation is going to be negative 1 divided by 3. We're going to multiply that by an x, and then we're going to subtract 1. I'm going to push my graph, wait for it to show me. All right, so I don't see any of my parabola. Now, if I use my previous knowledge of this, I know that this parabola has a turning point at 63. So I'm going to show you now how to fix your window. You're going to push the window key, which is next to y squared, y equals, I mean. You need your y's down here. This y max is stopping at 10. All right, we need it to be at least 63. So let's make it something higher than that. Let's do like 100. All right, and push graph again. So now when it graphs, now I can actually see the parabola. And here comes our line. Okay, looking at this graph, I can see that these two functions will never cross each other. There is never going to be an intersecting point. Therefore, this one has no solution. Okay, because there is no intersection. Okay, let's try another one. Here we go. I have my parabola and my line. Go ahead and pause the video, and I want you to get each of those y's isolated and typed into your calculator and graph it. All right, so here we go. I have my y's isolated. When I graph, you see what it looks like on my calculator. I want to fix my window to go back to the way it was. So to get my standard 10 by 10 graph, you're going to push zoom, and then option 6 is standard. I'm going to push 6. It'll give me my 10 by 10 screen again. So it's going to graph it for me. There's my parabola, and then here comes my line. And I see that they are crossing each other. It looks like at exactly one point, but let's make sure. Okay, second, trace, 5 for intersect. I need to get my cursor as close to the intersect as possible. There it is. And push enter 3 times. 1, 2, 3. All right, and it is intersecting at the point of 3, negative 5. Right? Don't let those decimals scare you. This point is at exactly 3, negative 5. So we have one solution, and it is at the point 3, negative 5. All right, we have one more problem to work out. Go ahead and push pause, get your y's isolated, and graph it into your calculator. Your graph should look like mine. I can tell that it is intersecting, but it may be 1 or 2 places. So we are actually going to zoom in. So we will push zoom, option number 2. I need to move my cursor over to where I want to zoom in at. So I want to zoom in this area, and I'm going to push enter. Here I can see zoomed in that it is intersecting at 2 points. So I'm going to do my second trace 5 option to find those 2 intersecting points. My calculator shows me that each intersect point has its own coordinates. So my 2 solutions for this function is going to be negative 2, 1, and it's going to be negative 1, 0. All right, continue to work on the worksheet that you have. If you have any questions, try to rewind, and I will be back tomorrow to answer any of y'all's questions. Have a good day.